First trend we're going to look at is the atomic radius. The atomic radius is the distance from the nucleus of the atom to its valence electrons. So just like when you're measuring the radius of a circle is from the center to the outside edge, so is the atomic. As you move down the periodic table, the atomic radius increases. As you can see, with each added energy level, the radius increases. So as you go down the rows and you add energy levels, you're going to increase the radius of the atom. As you move left to right, the radius decreases. This is due in large part to effective nuclear charge. Effective nuclear charge is the average charge felt by any electron in the atom. It is found by taking the number of protons in the nucleus and subtracting the number of shielding electrons. Of sodium, it has 11 protons. And if we're going to calculate the charge for this one valence electron, all of these 10 interior electrons into consideration because they're moving in between the valence electron and the nucleus. Magnesium example, we still have the same number of energy levels, 10 shielding electrons, but now we have 12 protons pulling those electrons in instead of just 11. Look at this table of the atomic radius trend. If you're moving from top to bottom, you're increasing in radius, and if you're moving, you're decreasing the radius. Let's move on to ionic radius. Ionic radius is measured the same way as atomic radius, it just deals with ions instead of neutral atoms. The trends are the same as well. So if you look at this table, if you're moving top to bottom, you're going to be increasing in radius. Then you get much larger at this line. Then again, you're still moving or left to right and you're decreasing in size. So why is that? When an atom loses an electron and becomes positive, it gets smaller. So if we look at this sodium atom, it has a 186 picometer radius. Once it loses that electron, its 11 protons can pull in the rest of those electrons a lot closer, and its radius is now 97 picometers. When an atom gains electrons and becomes negative, it gets much larger. So if we look at this fluorine atom, it has a radius of 64. Once it gains an electron, now it has to hold on to 10 electrons with just 9 protons, much larger. Isoelectronic series are any group of atoms and ions that have the same number of electrons. Oxygen with a 2- charge, you have 8 protons and 10 electrons. A fluorine ion has 9 protons and 10 electrons. A neutral neon atom has 10 protons and 10 electrons. A sodium cation has 11 protons and 10 electrons. And a magnesium cation has 12 protons and 10 electrons. All of those have different number of protons but the same number of electrons, hence the term isoelectronic series. Ionization energy is the next trend that we're going to look at. The ionization energy is the amount of energy required to remove an electron from an atom. Elements with a low number of valence electrons are very low in ionization energy. They give their electrons freely and without much energy required because it's easier to give up those few electrons than it is to take on several more to complete their octet. Elements with a high number of valence electrons have a high ionization energy, and they don't want to give those up freely. They want more electrons, and they're not going to give up what they have. Highest ionization energy because they already have a full stable outer energy level. They don't want to react with anything in any way, and that means not sharing their electrons either. You can see with the trend here, you're increasing as you're moving left to right, and you're decreasing as you move top to bottom. Helium has the highest ionization energy.
Created using Powtoon.